Dear expectors, my name is Jianwei Tai, and it's a great honor for me to share my research here. The title of this paper is shown below. It was completed by a multi-author from the University of Chinese Academy of Science, the Institute of Information Engineering, and the Boston University. Now, let me introduce the objective of this paper. As we all know, the speech produced by human beings contains lots of information. For example, emotional information, text information, background noise, and so on. For voice-based biometric authentication, only identity-related information should be used in speech verification tasks to improve the accuracy. Therefore, we try to find a method to decouple the attributes and features of the original speech so as to purify the speaker embedding to achieve this purpose. So let's talk about the motivation. Firstly, more and more biometrics are used as the authentication method, such as fingerprint, Face ID, voice print, and so on. Secondly, as the advance of the machine learning and the popularity of mobile devices, biometric authentication has been widely used in everyone's daily life. Intelligent voice assistant is becoming more and more popular. At the same time, voice print is also used in some famous applications on mobile phone, such as voice lock on Alipay and WeChat. And even Hi Siri also use simple speaker verification technology. Thirdly, the availability of in the wild dataset helps speaker verification system to become capable of dealing with real-world issues that require high accuracy and robustness in complex environments, like supermarket and restaurant. However, speech signal contain many information. When we listen a speech, we can know who is speaking, what is said, in what environment, and with what emotion. Therefore, the task of in the wild speaker verification is still challenging. There have been many excellent studies on this topic, one after another, and remarkable success have been achieved. However, the existing research still has some shortcomings, which can be summarized in the following aspect. They directly process the original speech, which contain lots of unrelated features other than one close to speaker identity. And they usually require additional supervision during the training. Process and encode each attribute as separate elements in feature vectors, which may not be easy in real world. And it's difficult to point existing model to improve the performance. To solve the above problem, we propose a novel Speaker Embedding Enhancement Framework by Adversarial Learning based Disentangled Representation named SEEF ALDR, which aims to minimize the impact of identity-unrelated information for speaker verification tasks by decoupling the identity feature from original speech. Our contribution can be summarized as follows. We propose a novel twins network-based speaker embedding enhancement framework to significantly improve the performance of speaker verification by combining autoencoder-like architecture and adversarial learning. And our framework follows the modular design to ease the porting of existing model without adjusting the structure of them. And we only use speaker labels to train the eliminating encoder based on adversary supervision to obtain the identity-unrelated information without additional label. And the figure shows architecture of the proposed framework. Given an input S from the original speech, the speaker purifying encoder extracts the identity purifying feature FP, while the eliminate encoder extracts the identity unrelated feature FE. Two encoders are trained based on twins networks, with the same network structure as the speaker verification module. The speaker identity label acts as a signal to train purifying encoder and also adversarially lead the training of eliminating encoder. Specifically, the eliminating encoder and the adversary classifier perform a zero-sum game. The adversary classifier tries to get the speaker identity based on embedding FE, while eliminating encoder tries to fool adversary classify by making prediction result even distributed over each identity label, thus erasing the identity information from FE. Finally, FP and FE are combined by the future version module to produce FS, and the decoder reconstructed the speech from FS to ensure that the new one is close enough to the original speech. So we can summarize the key idea of the proposed framework as follows. Our framework tries to decouple the identity-related information and the identity-unrelated information from the input speech by using adversarial learning. After training process, our framework can learn the distribution of identity-related information and identity-unrelated information in the feature space from the speech sample and decouple them confidently. To improve the probability, we follow a modular design. The encoder, classifier, feature version, and the reconstruction decoder are all implemented in form of the module. Then, we began to analyze the experiment of the paper. In this part, we first introduce on the experiment setup, and then show the result on enhance the speaker verification of existing module. Finally, we conduct the ablation study to evaluate the contribution of each module. We choose Vox1 and Vox2 as an experiment dataset to evaluate the performance. They are large-scale text-independent speech dataset, which are collected from video on YouTube. The basic information of the dataset is shown in the table. In our experiment, we only use audio file from them for speaker verification task. In order to verify the performance of our framework, we choose the state-of-the-art speaker verification module as baseline to point into our framework. And when reproducing this module, we ensure that the module structure, loss function, test data, and the similarity matrix are constant with those in original paper. After porting them into our framework, we retrained on Vox1 and Vox2 respectively. We choose two matrices, the detection cost function and the equal error rate, to evaluate the system performance. The following table shows the performance of our framework on dataset Vox1. As shown in the table, the result demonstrates that our framework can significantly improve the performance of each baseline, with an average improvement of 20.6% on equal error rate. And then, the following table shows the performance of our framework on dataset Vox2. As shown in table, our framework still can improve the performance of original module, with an average improvement of 23.8% on equal error rate. And the best equal error rate achieved by our framework is 2.61%, which is better than the result of most research. As shown in Feature 3 Part A, the identity of each speaker has a set of features, and there are clear classification boundary among each identity. Hence, it demonstrates that the purifying encoder can effectively extract identity-related information. In contrast, the Feature 3 Part B, the identity of each speaker is distributed in feature space, and the feature of each identity overlap significantly with each other. Therefore, it shows that the eliminating encoder is capable of erasing the speaker identity information, thus constructing the identity-unrelated representation. And we can observe similarity on the distribution as that in Figure 4, which shows that our framework is capable of decoupling identity-related and unrelated features effectively, even on the dataset with much more identities. Overall, making the contribution of the purifying encoder, the eliminating encoder, and the reconstruction decoder together, our framework can achieve better improvement of speaker verification over the baseline. That's the evaluation, the contribution of each module we choose the ablation study. And next, we begin to talk about some potential and interesting application of our framework in further work. Let's look at two interesting cases. One is the novel identity impersonation attack based on our framework. And another one is maybe a better sound event detection based on our framework. So now I have completed a brief introduction to this paper. If you have any question, please feel free to ask, and thank you for your listening.